In this video, we are going to practice solving linear equations in one variable. And so some of these are going to be very simple, 1 or 2 step equations to solve, and then others are going to be a little bit more complex, possibly with fractions or distributive property, something like that. So these are just a few examples to get us started. Solve each equation. So first, remember that you should be looking at the directions. It sounds obvious, but sometimes we don't read the directions. I tend to do that as well. So make sure you read the directions and then look at what you're given. And so in previous videos, we discussed simplifying expressions. And so remember that an expression does not have an equal sign and an equation does have an equal sign. And so these are equations we're going to solve, meaning we're going to have x equals something. So the goal here, when we have one variable, is to get the variable by itself on one side of the equal sign so that we can say x equals whatever it is. So in this first one, if we're trying to get x by itself, we want to get rid of that -8. And so the opposite of -8 is +8. So we're going to add 8 to both sides of the equation. -8 plus 8 is 0, so that zeroes out and simply leaves a -x on the left. And then on the right-hand side, we have 7 plus 8, and that will give us 15. Now we're really close, right? But look at the x, it's a -x. We want just x by itself. So we need to get rid of that negative. So you can think of it as the opposite of x is 15. That means x would have to be the opposite of 15. Change it around. Or you can think of this as a -1x, a -1 times x. So to undo that -1 multiplied by x, we would divide by -1. -1 divided by -1 is +1, so that would leave just x on the left, which is what we want. And then 15 divided by -1 is -15. And so in this case, x is -15. That's our solution. Now, if you feel very confident in your answer, that's it. You move on to the next one. Remember that you can check your work. And so in these, it's an option. You can check it if you'd like. You don't have to. Provided you did all the steps right, you get the right answer. If you're on a test, you may want to check, right? And so what I'm going to do is just plug in the -15 in the place of the x. So I have -8 minus a -15 equals 7. The two negatives here will make a plus. So -8 plus 15 is equal to 7. And then if I add -8 and 15, really I'm subtracting because the signs are different. I will get 7 equals 7. And so it checks. In future equations, you're going to have to check. It's going to be a requirement because sometimes you'll end up getting an extraneous solution, meaning you'll get one that's extra that doesn't actually work. When you're solving a linear equation in one variable, you don't have to check. You can, but you don't have to. All right, so let's look at number 2. We have 3x minus 2 equals 7. So to get the x by itself, we first want to undo any addition or subtraction. And so we want to undo that -2. So the inverse or opposite of the -2 is to add 2. So if we add 2 to both sides, the -2 and the 2 cancel out or add to 0 and leave us 3x on the left. And on the right, 7 plus 2 is 9. To finish, we have 3x. That means 3 times x. To undo multiplication, we divide. 3 divided by 3 is 1, so that leaves 1x. And then 9 divided by 3 is 3. And that's our solution. Again, you can check if you'd like. You'd plug the 3 in for the x, and you would see that it works out. All right, number 3, same directions, solve. This one's a little bit more complicated. So we have parentheses that we need to undo first. Notice inside the parentheses, we don't have like terms. We can't add the x and the 2. But what we can do to get rid of the parentheses is to distribute. That means multiply that 3 to each term in the parentheses. So 3 times x is 3x. 3 times 2 is 6, so we have plus 6. Bring down the minus 12 equals, and then on the right-hand side we have parentheses as well. So to get rid of those, we will distribute that 5 throughout. So we will have 5x plus 5. Okay, so now we've gotten rid of the parentheses using the distributive property. So now what we're going to do is look on each side of the equal sign and see if we have like terms that we can combine. On the left-hand side, we have plus 6 and a minus 12. Those are like terms, so we can combine those together. So we bring down the 3x. 6 and a negative 12 will give us a negative 6. On the right-hand side, there are no like terms. Once you combine the like terms on each side of the equal sign separately, now is your time to start bringing things across the equal sign. Notice we have more than one x. So in this case, we need to move our x's to one side and the constants, which are the numbers without a variable, to the other side. So I'm going to move my x's to the left. That's just what I usually do. You could move it to the right. It doesn't matter. So I'm going to take the positive 5x and subtract 5x. And I'm going to do that to both sides to keep it balanced. And that way the x's cross out or zero out on the right-hand side. So I only have x's on the left now. So 3x minus 5x are like terms, which is why I wrote that under the 3x. So if I combine that, 3 minus 5 is negative 2. So that's going to give me negative 2x. Bring down the minus 6. And on the right-hand side, I just have a 5 left. So now we've combined our x's. Now what I want to do is move that negative 6 over to the other side and move the constant away from the x. So since I have minus 6, I'm going to add 6 to both sides. Remember, you're doing that so that it zeroes out on the left-hand side. So on the left-hand side, we just have negative 2x, and on the right-hand side, 5 plus 6 is 11. Okay, so now we have negative 2x equals 11. So negative 2x, that means negative 2 times x. To undo multiplication, we divide. So we're going to divide both sides by negative 2. That will give us x equals. 2 does not go into 11 evenly. It also doesn't reduce. So negative 11 halves would be the solution here. Okay, number 4, we have x over 5 equals negative 3. Remember, this over, this fraction bar, is a division symbol, right? It's just a different way to write a division symbol. So this is really x divided by 5 is equal to negative 3. So to undo division, we should multiply, right? We want to get rid of that 5. So we need to multiply by 5. Remember that that means 5 times 5 over 1. So times 5 over 1, or just times 5. It's the same thing. The reason I wrote 5 over 1 on this side is maybe it will help you see that 5 divided by 5 is 1, right? Those just cancel out. Or if you multiplied straight across, you have 5x over 5, and again, the 5's cancel out. So that just leaves us x on the left, and on the right, we simply multiply. Negative 3 times positive 5 is negative 15, and that's our answer. All right, we've got 2 more to go. Before I do those last 2, I just want to show you my reference here at the bottom. I did get some of these examples from the OpenStax College Algebra textbook. It's a free online textbook. It's a great resource to have. So make sure you make note of that. If you want extra practice, that's the place to go. Okay, so number 5, this one looks a little more complicated. It's got the fractions. Notice that the variables, though, are all in the numerator. The denominators are all numbers. You can easily get rid of the fractions. That's probably the easiest thing to do by finding the common denominator and then multiplying everything by that. And so what you want to do is you want to look at all the numbers in the denominator and figure out what could you multiply each number by to get the same number. So you're going to be scaling up the smaller numbers to match a larger number. In this case, 3 times 4 is 12. So I can scale up all of my denominators to match the 12. I just have to figure out what to multiply each one by. So the first denominator is a 3. In order to get it to be a 12, I can multiply by 4. Whatever I do to the bottom of that fraction, I need to do to the top of that fraction so that it's an equivalent fraction. Now I need to do something similar to the 3/4. And so the 4, in order to get to 12, I would need to multiply that by 3. Whatever I do to the bottom of that one, I have to do to the top as well to keep it an equivalent fraction. And then the last fraction already has a denominator of 12, so I can leave it alone. So I'm going to multiply the red, so 4x over 12 minus 3 times 3 is 9 over 12 is equal to 2x plus 3 over 12. What you want to do here is combine the left-hand side, the two fractions. You now have a common denominator, so you can combine that into one fraction. The top, the numerators, 4x minus 9, those are not like terms, so you would just write 4x minus 9 over the 12, which is the common denominator, and that's equal to 2x plus 3 over 12. Once you get the same denominator and you have one fraction on each side, you see that we have one fraction on each side. What happens is the 12s can cancel each other out. So in other words, look what happens if I multiply both sides by 12. Because remember, whatever you do to one side of the equation, you have to do to the other to keep it balanced. And if you multiply both sides by 12, the 12s divide out and cancel out, so that leaves you multiplying by 1. So now your equation is simply 4x minus 9 is equal to 2x plus 3. So in other words, if you can simplify each side of the equal sign to one fraction by getting a common denominator, and if your common denominators match on both sides, so you have one fraction on each side with the same denominator, you can rewrite your equation without the denominators because they cancel each other out. Now we have a much more manageable equation. So now what we want to do, this is similar to number 3 above, we're going to move the x's to one side and the constants to the other. So I'm going to move this positive 2 to the other side by subtracting 2x. So 2x minus 2x, that zeroes out on the right, and it will give me 2x on the left-hand side. 4x minus 2x is 2x. Bring down the minus 9, bring down the 3. Now I want to move my constants to the right. So I need to get rid of the minus 9. I will do that by adding 9 to both sides. So that leaves me 2x is equal to 12. And now finally I have 2 times x equals 12. So to undo multiplication, I would divide, and I would get x equals 6. And that's the solution. There's more than one way to solve this, so we could have set it up differently in the beginning. But this is just one of the ways that you can solve it. Okay, my final example for this video is this number 6. So again, notice that we have parentheses. So the first thing we want to do is try to get rid of those. Since there are no like terms inside the parentheses, my next step is to look at the distributive property. So I can use that and distribute this 3. So 3 times 2x would give me 6x. 3 times a negative 1 is negative 3. Bring down the rest of the equation. Now I look at each side of the equal sign separately and see if I have like terms. So on the left-hand side, I have 6x plus x. Those are like terms. So that will give me 7x minus 3 is equal to 5x plus 3. So those were the only like terms. Nothing else was like. Now we start moving things across the equal sign. So again, I want to get all my x's to the left, all my constants to the right. So I'm going to move my x's to the left. So minus 5x That will zero out the ones on the right, and it'll leave me 2x on the left minus 3 is equal to 3. Now I want to move my constants to the right, so I need to get rid of this minus 3, and I'm going to do that by adding 3 to both sides. So that'll give me 2x is equal to 6. And then last, I have 2 times x. To undo multiplication, we divide. When we divide by 2, we get x equals 3.